Hey y'all, this week we're going to be talking about population. And to put that into context, this is a resources class and people are using these resources, right? We're extracting them. We talked about what the definition of a resource is, right? Naturally occurring thing that you can make money on. Um, so it's worth our time to talk about what the future of population looks like, and we're going to tie that back to resource use. So when we look at the population of Earth when we look at the population of Earth over time, for most of human history, it actually didn't change. So here you can see in this graph, this is showing global population over time. And notice that it doesn't really change until kind of the 1700s. Prior to that, it's basically a flat line. I think when we look at this chart, there's a couple of things that we can really pull away pretty easily. So going back to the beginning of human history, humans in their kind of modern form, we can just go back like 200,000 years. And for most of that time, people are fragile and people don't live very long without kind of the infrastructure of the modern world. And what that means is that there's a lot of complications, particularly childbirth, infants. If anyone's ever had a baby, there's a lot of things that could potentially happen there. And if we don't have things in place, so we're going to come back to some of these themes: sanitation, nutrition, medical care, vaccination. Without those things, we generally, as a species of humans, have a fairly high infant mortality rate. That's definitely not true anymore. And when we look at this diagram, again, looking at the kind of population curve over time, we can see that that really starts to change kind of around the mid 1700s, which is the beginning of the Industrial Revolution, kind of modernization. We're going to explore really two kind of distinct ways that humans reuse resources. The first one is an absolute no-brainer, right? People use stuff. So with a growing population, there's a growing demand for resources, food, water, a place to live, something to build your place to live out of, all of those sorts of things. So if a nation, right, if we're kind of thinking about this as within the confines of a particular nation, any nation, frankly, the more people there are in that nation, the more resources they're going to use. Super straightforward. But when we start to, again, go back and think about nations, what we quickly realize is that not all of them are kind of created equal, and not all of them have the same kind of per capita usage. And that's a term that we're going to come back to a couple of times. So what that really means is if we think about a developed nation, you guys did your carbon calculator assignment, kind of went through and looked at, that was, CO2 being produced, but you could draw a parallel to resources used, is that people in developed nations tend to use far more resources when compared to those in developing or undeveloped. So that is what we call per capita usage, right? So capita means 100, so per 100. So I know that sitting over here on the table behind the camera is my phone, right? So that's the phone that I use every day. And if I go back and think of just smartphones, I've probably owned 5 of them in my adult life over the course of the years, and that number is not going to stop. Eventually, I'll have to get another one, and there's resources involved, right? So actually, particularly, silicon for chips, rare earth elements, magnets, batteries, the indium in the glass, and all the different things that go into an iPhone. So that's very real usage of resource, and I've had 5 of those. 4 of those, again, I don't exactly remember. It's been a long time. But that's not true across the globe, right? And so you can see here, this is a map of cell phone ownership of planet Earth. And what we see is that there's a pretty big disparity between nations, and particularly what we talk about developed and either developing or underdeveloped nations. Many of those people have never owned a phone. The percentage is much higher of people that don't have some sort of connectivity, and therefore those people are using less resources. We're just using phones as an example. So again, more people, so just increased population is increased resource demand, but then we can also look at per capita, right? So is that particular population using resources at a higher percentage per person than in some other nation? I want to take a look at this population curve again and talk about some of the specific kind of fluctuations we can see. And generally, these are due to technological advancements, not necessarily like modern tech, but tech that was maybe modern, 300 years ago. the beginning of the Industrial Revolution. And so if we talk about global population over time, it's really interesting. So we can all take a trip to Constantinople, Istanbul. Right? There's the wonderful song about that my children sing all the time. So when Constantinople was founded as a city by Emperor Constantine, there were about 55 million people on planet Earth. That's bonkers, right? So if we look at planet Earth today, we have cities, or at least kind of urban areas, that are getting close to that number, what we call mega cities. We'll talk about those in a later video. But all the population of the Earth, as it was when Constantinople was founded, now in some cases live in one giant urban area. So also, when we look at this, you can see generally population trends go up. But actually, if we look a little bit more closely at this, we can see that there is a very negative, kind of barely perceptible negative slope in the kind of 13 and 1400s. And that shows that sometimes we can have things that affect global population in a negative sense. And that was, of course, the Black Plague in Europe. So the Black Plague was a virus. It was pretty terrible by all accounts. And as it tore through Europe, it killed 2 out of every 3 people. So overall, about 100 million people lost their lives as a direct result of the plague. But it takes something serious to affect the trend of global populations, right? Even COVID-19, fairly high death rates. It's not something that we would see at this scale, right? It's not changing the number of Earth's population by, billions. So another example that we can look at is actually wars. So political events can also affect population. Particularly, World War I and World War II, the casualties were extremely high. We had the Civil War here in the United States. And actually, if we look at birth rates across Europe, you can see, here, kind of 1918, 1919, there's a dramatic decrease in birth rates. And that's largely due because all of the young men went off to war. And as the casualties are very high, it takes a while for that to bounce back. If you look at the population of Poland during World War II, you can see a similar trend, right? So there are events that can change population in a negative sense. So going back to our population trend, we can kind of think about some population milestones. The Earth first hit 1 billion people somewhere between like 1805, 1810, which isn't that long ago, right? Like if you look at your family tree, you can, if you've got a good one, you can probably go back that far, maybe 5, 6 generations. And what we were thinking about socially, what was happening. So the per capita use is kind of all over the place here. Lewis and Clark were out doing their thing, finding his way to the Pacific Ocean. I think Thomas Jefferson was president. That whole Alexander Hamilton thing, that's the musical that we all know and love. All of that was happening when the Earth's population was about 1 billion. But as we tend to solve some of these problems that are dealing with infant mortality, I talked again about nutrition, sanitation, vaccination, and basic medical care, the population starts to increase fairly rapidly. And so bumping forward a little bit, when we get into the early 1960s, that's when the Earth crosses 3 billion people. So we've changed from 1 billion to 3 billion in, from 1810 to about 1960, pretty big chunk of time. So, JFK is president. I think he was assassinated in 63, if you're a history buff. The first soldiers were headed off to Vietnam. So when that was happening, that was 1960. So that's a big change in a short amount of time. If we move forward even a little bit further, thinking, 1805 to 1960, we went from 1 billion to 3 billion. If we go from 1960 to 2011, so 2011 was when our global population crossed the boundary of 7 billion. It was a big news story at the time. And I always like to think about my dad. Well, my dad's a great guy. I enjoy hanging out with him. But he was born in 1945. So when he was born, the Earth's population was about 2.5 billion. And he's knocking on the door of 80. He's still healthy. He's up there. He's doing his thing. And now we're knocking on the door, or have crossed 8 billion people. Counting global population is a little bit fuzzy. But currently we're hovering in the 8 billion range. Um, but remember, 1805 to 1960, we went from 1 billion to 3 billion. And from 2011 to 2022, that's when we crossed the boundary that we added another billion in that like almost decade, right? In that 11 years, we added 1 billion people. So it's a big problem, right? So how does this all happen? What we can kind of look under the hood a little bit. And the first thing to think about is, well, how many people are born every year, right? So present day on planet Earth, and again, it's a little bit hard to get a very precise number, but we can kind of think ballpark. There are about 140 million babies born per year. Well, so that has to be balanced, or you would hope that that would be balanced by deaths. So that number, 140 million, obviously the next thing you look at is how many people die every year. So that's not the same number, right? So we've got 140 million born, 60 million dying, and that leaves a balance, right? That leaves a balance or a surplus of the population as it grows per year. About 80 million extra people, more problems, right? Got that up here. And again, these people are obviously distributed in kind of developing nations, developed nations, and so the per capita use is kind of all over the place here. But it shows us that global population changes by an average of 80 million people per year, but that number changes over time, right? So there's more people born every year, and this number goes up slightly as well. So this is just kind of a snapshot in today's world. So what does that all mean? We can talk about growth rates and kind of think about a big complicated equation. I'm tempted to show that to you, but I don't think I'm going to. We're just going to look at the results, and here they are. So Earth's population in the present day is growing at a rate of about 1.1% per year, meaning you take the population, 1.1%, you add that to the total. And if we think about what that means going into the future, well, theoretically, if we were to continue at 1.1% growth rate, it paints a pretty grim picture, actually. So let's, if we go 100 years in the future, you can see here's a diagram that shows the equation at a 1.1% growth rate. When we get into, 100 years in the future, 2120, so when we get about 100 years into the future, 2120, 2130, in that range, we start to see the global population is predicted to be over 20 million people. Most people who study demographics, demographers, would say that's not possible, and we likely won't see that. And we'll talk about why in some other videos. The Earth has a carrying capacity. There's also, as nations become developed, their birth rates tend to drop. So developed nations are pretty close to zero population growth. And that's a magic number. If we integrate all the babies that are born, all the mommies that are having the babies, and the dads that are part of the picture as well, our global fertility is at about 2.56 babies per mama. I'm going to think about what 0.56 of a baby looks like, but we know math and we understand averages, so it won't make us queasy. But generally, you've got a mom and a dad, and they have a baby or two, and they replace themselves. And so this number actually predicts growth. We've talked about ZPG, or zero population growth. That's a different fertility rate. The magic number that the demographers use is 2.1 babies per mama, meaning you're basically replacing themselves. But there are, tragedies that happen. There is still mortality, there's sickness, and that's just a kind of hard part of life. And so that's where the 0.1 comes from, right? Because if we were to get rid of all of that, would obviously be 2. But 2.1 is zero population growth. If global population is here, things will stabilize. And what we do see is that this number does slowly change over time. And I talked about how, so this is integrated for all the countries on Earth. Some countries are far lower than this. Some countries are seeing a decrease in population, famously Italy and Denmark, just to name a few. But as other countries become developed, their tradition of having large families, 5, 6, 7, 8 children, that tends to decrease over time. Like I said, we're going to explore that concept in a future video. But when we look at how this plays out, we see that generally most people assume that global population will plateau around, like 11 to 12 billion, we'll start to see this kind of flattening effect, and potentially even a slow negative if this fertility rate goes below that. Well, that gives us a framework to start our discussions about resource use and population, overpopulation, how some of these demographic transitions happen, and I'll go ahead and catch you in the next video. All right, bye.